Okay, so after all that groundwork, let's go ahead and take a look at some homework-like problems. Make sure we can use the technology to actually answer things, as well as to kind of get used to how I present things on a quiz. Actually, there's a little nuances that I'll discuss. So what we're going to be doing for each situation is we're going to find the value of all the angles. All right, and to shorten things up, we're just going to find the value of x in all these situations. And I think in terms of the angle, you just basically substitute your value in for x, right? Do the little operation, you get the angle. So I'm going to just focus on getting x, because once we have x, then we can basically find the angles by coming back in and just substituting it in. And I just want to save a little bit of time. So you guys can finish it up, but I'll get you definitely in terms of finding x. And the first nuance that I want to mention to you guys is when you look at this and some of my terminology here, if you see an angle measure, right, or an expression representing an angle inside of an angle, you should assume that I'm talking about that angle measure right there is given by 5x plus 3, right? And so that guy right there is also. So you can kind of see me doing that several times, right? So here's the expression, it's representing that angle, right? Here's the expression, it's representing that one. An expression right here representing that one, here and here, here and here, here and here, right? So those are pretty easy. But then as you look deeper into this handout, and when things get a little maybe tight, if you would, right, I start using a different type of notation. So here, definitely in this case, this is a very small acute angle on my word processor, so it was kind of hard to stick that expression inside of that parentheses without it getting floating around too much and getting in the way of these guys. So my new notation is, if you see an expression with a little line in it, right, that's your way of knowing that this angle right here is equal by that, right? This line is indicating that this angle here and this angle here are given by that expression, right? And then last but not least, I'm using both. So here this expression is in this nice little angle, so that angle is given by that expression. But over here, because of the acuteness, right, this line is indicating that expression is equal to that angle, and that expression is equal to that angle. So the first thing, again, I wanted to do is just go through, you're going to see this on my quizzes in the future, and I just wanted to make sure that you guys were clear, since I'm not around proctoring you, right, that you knew how to read my pictures, all right? So hopefully that clarified it. If not, jump in and ask some questions. So how do we find x in all these situations? Well, we take advantage of some of the definitions of geometry we've talked about in the other videos. Number one, we are looking at a vertical angle situation here, right? Because we have two lines that are intersecting each other. And it just happens to be that the two angles of interest, right, 5x plus 3 and x plus 83, happen to be, right, a classic opposite, if you would, vertical angle. So what do we know about those two angles? They have to be equal. All right, that's what we pretty much learned, right, in all our groundwork. So as a matter of fact, these angles here would also be equal, but there's no information for x there, so I'll use what I got. So for the two expressions I have, they're vertical angles. That means they're equal. Now I have an equation to solve, and we can find x. All right, and so how do we do that? Maybe I subtract x from both sides and subtract 3. Right, play my balancing act. I believe I end up with 4x on that side and 80 on that side. Divide both sides by 4, and in this case we end up getting x equals 20. So there's the value of x. Of course, to finish it, to find the value of the angles, you just plug it in. So 20 plus 83 would give us, what, 103 there? And so 5 times 20 is 100 plus 3 gives us 103. So to actually answer the question, right, the angle is 103 degrees, 103 degrees. But as I shared with you, what I'm going to focus for just time's sake is just finding x, and I'll let you guys go back and substitute it in and find the angles. All right, so that's that demonstration. So the next situation, letter B. We're not talking about vertical angles here, we're talking about a transversal, right? There's one parallel set of lines, and there's the transversal that's coming across them. And so we got to find the x for this situation. And so, you know, putting our kind of thoughts together here, right, if we kind of put our thinking caps on, right, we know that they're not equal, right, because they're not alternating interior or exterior angles of that nature. They are on the same side, right? And so on the same side, they're not corresponding either, because this angle, right, is supposed to be corresponding with this angle, right, and this angle is supposed to be corresponding with that angle. That's when I would have equality. However, we do know that these two angles here, if I add them, right, I would equal to 180. And what I have in red is equivalent to what I have here in red. And what I have here in blue is equivalent to what I have here in blue. But if these two angles here, if their sum equaled 180, that means that these two guys in here, because of the equivalency, they would also have to be equal to 180. So to set this up, I'm going to take 2x plus 5, I'm going to add to it 3x minus 10, and that is supposed to equal to 180 because these essentially are going to be supplements. These two guys are supplements, these two guys are supplements. Using the corresponding angles, that means that these two guys have to be supplements. So there's your setup. I now have an equation to solve, so now I can find x. So combining like terms, I believe we get up with 5x minus 5 equals 180. I hope I'm doing the math right. Perhaps we add 5 to both sides. That gives us 5x equals 185. Dividing both sides by 5, we get x equals, let's see, 18 divided by 5 is 3. Remainder of, I think, 37. So in this case, x is equal to 37. Of course, to find the actual angles, substitute it in. I think, substitute it in here, and you'll find this angle measure. Substitute in here, and you'll find that angle measure. And again, I'll let you guys finish that off. I'm going to concentrate on finding x and using our definitions. Let me do one more, and then we'll cut to another video. Here, what we have is, again, another transversal situation. All right, and in this transversal situation, it's a little easier than that one because this side and this angle are what we call alternating, right, exterior angles, basically. And so because they're alternating exterior, that means that they're equal. Or you can just basically use the vertical angle argument, right? This angle is equal to that one. This is anterior to that one, right? Or that's corresponding to that one. So however you get there, right, that angle corresponds with that angle. So that must mean that this side, this angle measure is here, and so it must be equivalent to that angle there. All right, so what we have is that 11x minus 37 has to equal 7x plus 27. All right, so we're just basically taking advantage of some of the theory, some of the correspondence, some of the geometry. So however you get there, exterior angles are equal, or you can just see the vertical angle stuff and corresponding angles. So lots of ways to get there, they're equal. So now we have something to solve for x. So solving for x, perhaps I subtract 7x from both sides, add 37 to both sides. Oops, that's 37, and that cancels out, leaving us with 4x. 27 plus 37, I believe, gives us 64. All right, and then of course divide by 4, and we get that x equals 16. All right, so the x value is 16. I'll let you guys go ahead and find the actual angle measures, right? 7 times 16 gives you a number, add 27, you get the angle. Since they're the same, it should evaluate the same thing as there. All right, so we're already 8 minutes into this. We looked at a vertical angle situation, and we looked at two transversal situations to solve for x. Let me cut to another video where we start talking about triangles. I'll see you guys then.